All right. Welcome, everybody. We are here now. This is the Owl E Moments first podcast, and I'm so glad that everyone can attend. And just the thing about, Owl E Moments, as I mentioned before, we're just trying to keep it simple. And the reason we started this was there is this wave of innovation in American manufacturing. And my guest today, Robert Quinn, we both have that same type of passion and similar background too in the semiconductor industry. But the thing that we see and what I've seen too is that there's a lot of technologies out there that just fail because there isn't adoption. And the purpose of these podcasts are to, one is to educate folks of, what's out there. Advanced manufacturing is not dead. It's actually revving its engine again, and always has. And there's just so much technologies out there, and we're just going to take a bit of time to one have some straight talk about what's really working, what's not working at times. There's topics of change management at times. It's not just about the data, but also we also have incorporated in these podcasts as live Q&A. So think about that Forrest Gump thing of life is a box of chocolates and you never know what you're going to get. Well, we know the theme is going to be technology, and we're going to do our best as we keep producing these podcasts to go ahead and share that. So with that, I just want to say today joining me, we have Robert Quinn. He is, I would say, one of the true evangelists and expert storyteller, fact finder on the semiconductor industry. He's got over 25 years of experience. He's built Quinn's Media, and there's other things that he's involved in too that we are going to see as we go through this podcast. But we're very fortunate. His reach on LinkedIn, I want to say, I think is like 12 million impressions a year. Yep. And 65,000 followers. So I've been following him for about at least 4 or 5 years, and then we've got a chance to connect over the past year. So very fortunate to have you, Robert, and welcome to this podcast.
It's my pleasure. It's great to join you, and it was great seeing you at Semicon West. We had some great conversations. It was an amazing event, and really enjoyed that. That was incredible.
Thank you, sir. Thank you, sir. Yeah. So we're going to go ahead and get started. I've got some questions for you, Robert, and I know you probably have some questions for me. But one, not everybody that's like close to LinkedIn may know about you or in that sector or vertical. So for our audience, can you walk us through your journey in the semiconductor industry, like from your roots to kind of where you are today?
So I had a really interesting background in this industry, and it's one of the reasons why I have so much passion for it is because, it takes all types of people to make this industry happen and make it work. And started off actually in 1997 at Applied Materials. My roommate got a job at Applied. I was a guy that worked on cars. I've been working in mechanic shops and building old hot rods since I was 12 years old, 14 years old. Like it was, it's always been a passion of mine. So natural knack for mechanics and physics and trying to figure things out and make things work. But ended up applying for this job at Applied Materials, Operation 100, mounting chambers to engine stands. Before I know it, I'm actually got the job. Before I know it, I'm running the manufacturing line as the lead of the manufacturing line. My boss came to me and said, "Hey, I'd love to get you, going into chamber test and final test. Where do you stand as far as your diplomas? What schooling do you have?" Well, there's a little problem there, Eric. I was a high school dropout. Mm-hmm. So ended up getting my degree through Applied Materials and working my way in and getting the degree, went into chamber test, went into final test, and ended up having really a lot of different exposure to the field. And I was flexed around a lot. So I worked in EPI, I worked in ALD, I worked in PVD, CVD, RTP, all the different departments, and helping them in the field and making these machines that we, that make these computer chips for us today run, and doing startups around the world. So I had this really unique landscape where I was able to see a lot of different companies, and traveling to IBM, Global Foundries, Intel, all these different fabs, the Samsung, all these different fabs around the world that that use this semiconductor equipment to manufacture chips. And so I had a deeper as the years went on, I really got a deeper understanding, and went into a little bit of process engineering, equipment engineering, and a lot of different platforms. But it was really good. It was really good experience, incredible knowledge, being able to learn the physics and be able to understand this industry and what we do, and how this industry works. I actually have a nonprofit organization where I talk to kids, and trying to get kids excited about the semiconductor industry. And one of the things that, kind of my dyslexic brain is able to do is to break down this technology and to really make it so it's understandable for the average person. I've been married for over 20 years, and my wife still tells people I work on computers. like how do you people, they just shut off, they turn off when they hear the word semiconductor.
Right.
Okay, yeah, you're just one of those guys.
Over that.
Exactly. And so I have a nonprofit organization where I actually like to take kids. The goal of is to build a 52-foot semi, an 18-wheeler that goes to schools around the nation, that gives kids the aha moment of, I learned what semiconductors are and they're cool. And I want this to be a part of my career forever. And so we suit the kids up. We take them into the J.J. Pickle University of Texas lab. We strike plasma on the tools. We have fun, working on the equipment and getting them excited there. But then I teach a class, and one of the classes I teach, I have this like kind of intro where I tell the kids, say, listen, these machines that we work on, they pump down to a vacuum of 10 to the negative 9 torr. That's deep space vacuum. We're injecting a plasma as hot as the surface of the sun. We're exciting the molecules and the atoms inside of these chambers. We're now doing processes like atomic layer deposition, where we're putting a single layer of silicon atoms, a single layer of atoms on these chips to make transistors today. We're stacking atoms. We're now down to 3 nanometers. That's 21 atoms wide. So we've gone from a single transistor. If you remember in 1954, they had these single transistors that were about yay big. Chip. Cerebus sent me this. This is a chip with 2.6 trillion transistors. Let's see if I can get it in the video. 2.6 trillion transistors and 850,000 cores. We're stacking atoms to make transistors today. And people don't understand that technology and this level of we've followed Moore's law through the last, we've followed this Moore's law through the last, 74 years, I believe it's been. We're doubling transistor density, and now that changes. We've reached the 1 nanometer, and how does that change, and how does the industry change to that? But getting these kids excited about this industry and talking about this technology, where it's going and where it's been, and what we're doing with it, and absolutely, it's a parabolic. We've watched Moore's law go like this on the chart. From today forward, it's vertical. The chart,
and that was the thing, like, that I noticed at Semicon West in Phoenix. What I loved, being able to go back and get that type of tech talk. And one of the guys, I think it might have been from Lam, but talking about the chip, instead of making the chip and the density horizontal, now you're stacking and you're making these verticals. So those via through holes and all of that stuff, it's like making little skyscrapers, to get more processing power, which I thought was like just amazing. And me being away from it for I would say 2010, roughly, as far as inside in the chip industry, so that's 15 years, and a lot of concepts haven't changed too, in that, like ALD, atomic layer deposition. I think when we talked, you were at Applied Materials in 97, right?
Yeah.
And
Yeah.
you went from 97 to 02 or something like that.
On and off 08.
Yeah,
Yeah.
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 Yeah,
And then,
08. Yeah, yeah.
yeah.
So I was there from 88 to 02. And when we started, it was just etch, um, chemical vapor deposition, and epitaxial growth. Those were the three chambers.
Yeah.
10 years later, we've got 57 process chambers. The ALD, I was part of that introduction, the low K CVD chamber, different etches and so forth. But just these densities and these geometries, and to stir that next generation of how do you get interested? Like, there's a lot of big push about STEM and stuff.
Right.
Yeah, that's great. But like, see the hands-on application to it and what you can do. I mean, when you got these big systems that are, I don't even know. I mean, back then, a PVD system, I want to say, was about $14 million or so, 15 million in 2000. I don't even know what the price are of some of this equipment now.
Millions. Yeah.
It's in
Millions
the
of
tens
dollars.
of million, and stuff. So, but yeah, that's just so amazing of that. Now with your journey of there to like now, like where, I mean, you are like this, I mean, evangelist for semiconductor, and you have a big sphere of influence as well.
Yeah.
So talk to me about some of these conversations you've had, like at the Congress level, at this CHIP Act level. Could you elaborate a little bit on that?
So I recently got flown out to Smart USA reached out to me and flew me out to DC for their Semiconductor Digital Twins summit that they did. And this is through the Department of Commerce funds, NIST, which funds I think is part of Smart USA. And they flew me out to that event. So to see how the technology is going to be changing with digital twins is absolutely amazing. And there's a lot of big investment coming from Department of Commerce into semiconductor and how they're investing all this money to grow that. And they're investing in digital twin technology. The Department of Commerce is. They're making sure that I truly believe that we've gone from 200 millimeter to 300 millimeter. Now the goal was 450 millimeter, but I think it goes from 200 to 300 to now digital twin. And we're going to see that digital twin influence in the semiconductor industry in the future. And I think that's how things evolve in the future as well. And but it's been great. I've also been able to work with other countries as well. I've flown out to the Brazil, lecture at the University of Sao Paulo. I've also been able to fly out to Oman and speak with the royal family and the Ministry of Oman as well. And having that influence with the different governments and the countries, and they really have a lot. They have a lot to learn. This is an enormous ecosystem, and there is so much to know. There's so much to comprehend. The supply chain to this industry is ever evolving and just enormous. There was 100,000 people at that event I just went to in Taipei, and they were all there to try to get in front of TSMC. But TSMC needs that 100,000 people. That's how big the ecosystem is. They need that 100,000 people to supply their supply chain and to keep them going. They're not doing it alone. Nobody's doing this alone. This is absolutely an incredible ecosystem and what it takes to make this happen. So,
that's great. Speaking of supply chains, there's the geopolitical, I'll just say it, the tariffs that have been put on, and us being a bit of a protectionist type country at the moment, and the cost of these tariffs. You and we've had conversations. Could you expand a bit of how you see, and I think it's actually a company you work for too, about processes and ways of bringing in, importing some of these electronics that may have high tariffs, 25%, whatever, 50%. How is that being done? Because that's like kind of taking an advantage of an existing process, but making it a bit better. Can you talk about that to offset the cost? You don't eliminate the tariffs, but at least you can offset some of it.
Definitely. So I'm not only Robert Quinn, the semiconductor industry ambassador, but I'm also the director at a company called PartStat. And PartStat's doing really cool things, innovations with the digital, trying to offset these tariffs. Basically, our basic thing is what we do is we're a 3PL company. We come in with our finances. We have $1 billion of capital per customer that we're able to purchase chips for. And so customers will come to us, such as large automotive companies, everybody from GE, all these big, the Foxcons, all these big companies will come to us. We'll buy those chips for them. We will move them into a free trade zone vault where we store those chips for them. And our vaults are EMP resistant. They're halon rooms. The chips are stored in nitrogen and nitrogen purging cabinets where they're able to safeguard them for long periods of time. And we're able to disperse those chips to them over 5, 10, 15 years, so they're able to have a supply chain of material here in the United States. I guess our biggest kind of claim to fame is GE. Whenever the COVID came around, we were able to actually, GE was one of our customers and we had their chips. So when the pandemic came through, and they had to build those respirators for the COVID patients, GE was one of the few companies that was able to produce those because we had their chips, and they were able to call those chips for. They're able to call all those chips at the same time. And so that was an incredible opportunity for them to have that supply chain here at home, especially when nobody was making the chips anymore. And so it's a great way to defer and to kind of offset your risk management whenever you're doing that. But essentially we're able to go in there and buy that inventory and store it in our facility, and they can take that capital and reinvest that capital back into the business or to any other parts of of investments to capitalize on that investment as well. So making way more money than they would have like holding that millions of dollars of inventory in a warehouse somewhere. So
right. The other thing about that, because I did work in supply chain as well as a director of supply chain, and went to some training at the Bureau of Industry Standards down in Southern California. So the whole thing of transfer of control, imports and exports, restricted countries that you can sell or buy from. The thing you touched on, though, back then, and this is probably, I don't know, 08, 09, we weren't even talking about environmental storage, like what you're talking about with these semiconductors and whether they're clean rooms or nitrogen, because the stuff has to be able to sit and not age and get defective and so forth. So that is a great example too. And as a taking ownership as a buyer of being able to, hey, well, if maybe the tariffs go down a little bit here, I'll take a hit right now because I need it, but I still got supply that I can take later and be able to offset some of my costs. This way, I don't have to pass on the full brunt to the customer. Maybe I'll absorb some and do it a little bit smaller. So that's great.
And the plans are in the future, the tariffs go down. This is kind of we're in a posturing, a geopolitical posturing environment right now, and everybody's posturing and trying to set the standards. But I believe the tariffs eventually go down. But the real thing is that you're buying tomorrow's chips on today's dollars. We all know one thing for sure, 100% sure, is that the price of chips goes through the roof. And the cost of chips is going to be extremely high in the future. All these fabs, when they come online and they hit 100% capacity, I can promise you the chip prices will go through the roof. And so it's good to see that and to see how that we're going to be able to build that infrastructure and that supply chain for those companies as well.
Perfect. You touched on digital twin applications. I remember our conversation we had too was about like what you had an opportunity at that Smart Manufacturing Conference to put on some goggles and be able to virtually look at a chamber and so forth. And I know like some of the companies like Lam is doing some strong partnerships with community colleges to help teach and train and co-educate with the community college for folks that may not be in a major city, to be able to see these chambers, understand and troubleshoot and so forth. Can you walk us through what that felt like when you were put those glasses on and
Yeah, that was cool.
working in that
That was really
environment?
cool. I mean, digital twin technology, the coolest thing about the digital twins are going to change everything. The way that we train students, the way that we're able to increase yield, we're able to integrate that with artificial intelligence. And now we're able to say, hey, we've got a vibration at the robot at 6 o'clock. Let's plan on a maintenance, for changing the robot bearings during the next takedown. It'll be incredible for yield, adjusting gases. No tool is exactly the same. Every flow, every MFC, everything is a little bit, has just a little tweak, a little difference. And to be able to virtually adjust that and to be able to see that virtually, we'll be able to do a lot with digital twin technology. And I'm really excited about it because I think it's going to be incredible for training. Can you imagine? I've been on the floor with, I've been training all these people for all these years on the floor and working on this equipment. To be able to get somebody on the floor that actually knows how to open an operating system of an applied materials tool or a TEL tool or a ASML tool or different equipment and be able to navigate that, that operating system. It takes years to really become an expert at that. And like to have that know-how and to be able to do that and be able to train people in colleges and universities and community colleges around the country, around the world on that, that'll be a huge productive production. We'll be able to increase the workforce and be able to train them up and get them up to speed really fast.
And the thing, like one of the panel discussions at Semicon was about changing the game of how we educate. I remember that the Lambs executive was speaking about that of we can't educate like the way of the old. We've got to be able to be more nimble, more agile, and digital twin definitely helps get you there. I mean, I remember like when I went to DeVry to get my degree and working on the test environment in applied materials, I swear, I think I only used 15% of that degree, because you're troubleshooting systems, it's electrical, mechanical, and I wasn't the engineering developer type, so I was in the operations side. So, but that degree helped you get there. Now you take that back in '88, and now you got where, we didn't know what a semiconductor wafer was, in Chicago, DeVry, and to be able to have that exposure and see what a chamber's like in the video. And then with the younger generation, catch them at school, catch them at 3rd or 4th grade, to be like with your truck you're talking, be able to put that on. I mean, that's a huge wow effect to I want to be that. Let me go,
It was really cool.
The barrier of entry is lower cost too, because community colleges, it is a bit more affordable,
Right. And not everybody can afford a $300 million machine, right? To train people on. And so how do you get that virtually? How do you get that training on with those students, to understand this equipment and see how it operates and to be able to catch all that data? You'll be able to see it virtually on another side on the digitally. But being able to having those goggles on and being able to actually move around and pick up wafers and press the on button and doing all that stuff virtually, it was just incredible. It's really cool. And that's kind of one of the visions for, what I would like to see this SIMU and the Semiconductor Industry Mobile Education Unit, where we're able to move it around the country and taking it to underprivileged schools. Right. How do you get not all these kids have access to this, a fab or this industry. So how do you bring it to them? And, and get them excited about it and seeing, what we're doing virtually and, plugging that, we have to create that spark. We have to give that kids that, I learned what semiconductors are and they're cool. And I want it to be a part of my career forever.
Exactly.
So, how do you get that spark? And I think VR and the digital twin, that's going to be a big part of that.
Yeah, I got to meet some of the community college areas at Semicon West. There was a strong presence of New York and what they were doing. Texas had their community college stuff. folks from the Arizona, Phoenix area, and the common vibe was that willingness of technology players. LAM is a big one of really partnering with community colleges to help educate, to help, which is great. And the whole thing about, the shortage of
Yeah.
workers that are going to be, I mean, this is definitely one path that as other equipment manufacturers and so forth really have that true partnership of education and business coming together is really, really powerful.
Definitely.
So there is another question I have for you, and this is my last one here, is that how does you got these semiconductor industry executives, all the big players, okay? How do they keep up or not able to keep up with all these emerging technologies? Have you run into situations where you might be panel guesting them and talking to them and they don't know an answer or something to a topic that you want to bring up? Has that ever come across you?
That's definitely something that, you have to learn how to speak multiple languages, and CEOs don't speak engineer. And it's one of the things I learned. I was actually at the Semicon Europa event, and we had 7 of the biggest CEOs in the world sitting in front of us. And somebody asked, what do you think about neuromorphic computing, and how is this going to affect the semiconductor industry? Well, neuromorphic computing is a defined architecture that people are using in artificial intelligence. It's running artificial intelligence around the world right now. And all 7 of these CEOs looked at each other and they said, what's that? And I was like, oh my gosh, they don't speak our language. So how do you speak a language that CEO, CTO, engineer, and 9th grader at the same time, right?
Yeah.
Because you want to make sure that you cover all those bases. So whenever I write and talk on LinkedIn, I really try to bring it down to an understandable level, like I'm talking to a 9th grader, right? And because that CEO doesn't understand a lot of that technical jargon. And you go to a lot of these conferences where, somebody with a PhD is speaking about something. And it's funny because he's got an audience of CEOs and executives. They don't know what he's talking about.
Yeah.
So, like, how do you really break this down to a digestible bite size, where people can understand what you're talking about? And it was funny because I was actually asked to go speak to the royal family in Oman in the ministry out there. They flew me out there, and right before I'm fixing to get on the airplane, a friend of mine reaches out to me. He says, by the way, you don't educate royalty. And I was like, well, what am I going to go do? So you know what? I'm going to teach them the same class that I teach my 9th graders. And so I teach them that story. We these chambers that we pump down to a vacuum of 10 to the negative 9 torr. And I told that whole story to them, and they're just like, this is awesome. I feel like a physicist. This is incredible. How do you keep that jargon, and how do you keep that to an understandable term? Not everybody speaks semiconductor. Not everybody speaks that language. And people are starting to hear the word semiconductor more, and they're like, they're interested in it, but they don't really know what it means. And to really break it down to a level to understanding that we are stacking atoms. We're making chips at atomic levels. And to break it down to that type of level, and what the sun is, what deep space vacuum is, what an atom is. And so you're able to understand it from that level. I think that that's a good way to be able to talk about things. And when you're presenting and having those conversations with executive level people, you always have to be conscious of that, for sure.
Sure. Great. Well, this is great, Robert. Is there any questions that you have for me?
I have plenty of questions. I'm really interested in what you're doing as well. You're working in this digital twin world as well, and you're working with a lot of this, trying to people to understand and teaching and educating people and creating that environment. So it's a immersive, visual environment as well. What is your journey? What is your journey to get here, and how did you get started with OWL movements, and how did you get that going, and what are you doing there?
So, well, the journey, I have to say, is like a 37-year tech journey. 25 years in Silicon Valley, then back home to Chicago now. And that's another like 12 years in Chicago from 2013. The Silicon Valley ride, I do got to say, the applied materials, being from a engineering tech working up to a divisional manager responsible for 300 million of shipments annually for the CVD division, and then being sent to TCG to be a change agent, help turn that around. That I learned so much in that span,
Mhm.
and then getting exposed to solar, doing some of the stuff with Solyndra from a supply chain perspective, and buying, have $150 million worth to spend, all robotic, Cartesian robots and all of that. A bit of hard disk drive sputter for Seagate. We had
Yeah.
one of the general managers, Kevin Fairburn from Applied, became the CEO of Innovac, and we did the sputter equipment with the same concept of the producer platform, but instead of doing 200 disks sputtering, we're 900 disks sputtering per hour. And
Wow.
I'm a supply chain director there, and I'm having conversations with gate valves that normally in semiconductor, 1 second, 1.5 second close speed. We're talking open and close at 0.9 seconds speed in
Wow.
order to get that throughput. So between that and then also industrial automation set up with Sabre Engineering, I really got a broad, I'll call it portfolio perspective and experience in technology. And then coming to Chicago, I fell into digital commerce in 2019. And that's where with In River, which is a product information platform, just think of like Milwaukee Tool when you go to buy, you're on your phone and you're going to buy this drill or sawzall, and all that information for you to make the buy decision, the digital asset. I know how to architect all of that. I know how to data model all of that. And doing that and then going to a integrator to learn how these business systems, we call it MOC concept, which is microservices, API first, composable, and headless systems. The situation now is there's so many different business systems that one platform can't do it all. So you may have an SAP on the inbound of data, a PLM, an AutoCAD system, specifications coming into a product information management system, a PIM, then outbound to a CMS, Adobe, Magento, Amazon, Home Depot, well, all these different channels. Well, to bring all that digital commerce together, someone has to do it, and it's a lot of times it's systems integrators. But one of the things that really got me the last 6 or 7 years is we would talk about going into industrial manufacturers.
Mhm.
A branded manufacturer is like DeWalt, is like Milwaukee Tool, it's Lincoln Electric with the welding equipment. But Lincoln Electric also has industrial robots. They got some partnerships with KUKA, and they're doing industrial welding and stuff. Now that is discrete manufacturing.
Mm.
And that's what got me, because none of these companies, and I do have a partnership with In River, but I'm going to help them get into that industrial discrete manufacturing environment. So
That's
by
great.
having the digital commerce and then digital twin that I saw at the beginning of the year, you know, there's so many umbrellas and verticals under digital twin, like what
Yeah.
you were talking about in that application and simulations and with the FAMs. I'm looking at it from the complex selling side, what we call
Mhm.
CPQ, configure, price, and quote, and digital visualization to make it easier to sell, to make that salesperson a bit more educated on how to sell. Because in our world in semiconductor chambers, it's a process engineer
Yeah.
that's selling to TSMC. It's that deep tech talk. And with digital visualization, you can help that. You can also help it on the service and warranty side.
Yeah.
Think about it when you blow out that assembly, and you can accurately order the right spares parts and
Mhm.
stuff. Spare parts identifiers are going to be part of the past when you
Yeah.
can take a 3D model and make it lightweight and so forth. And then the other piece that really gets me is the education side.
Mhm.
I really see that, like what Lamb is doing. I mean, that's not in part of our roadmap yet, but that is definitely something that I want to get involved in. because the same passion you and I have of how do we make a difference for this industry,
Yeah.
to be able to thrive and not just survive. And so I think digital twin is coupled with agentic AI. I'm also pretty proficient in AI applications and agentic AI. And so that's another topic, but that's definitely, those are a 1-2 punch that a lot of my industry, I'll say competitors, don't see that, but I have some good partnerships with some very good trusted SIs, like Omega Point is one of them too. So that's how I got the OWE Moments, and it was like, all right, let me launch in May, and was working on it in the beginning of the year. Went back to school, University of Illinois, for a digital marketing certificate, graduate certificate, but I only got one class. Now I got 2 more to go next year. So that's how I got there. Yeah,
that's great. With digital twin applications emerging, what are the areas you're targeting? I mean, there's just an endless amount of areas to target to help benefit discrete manufacturing and semiconductor industry. Like, what are you targeting there? And it just seems like an endless, like I brainstorm with digital twins with what is the emerging technology and where is it going, and it's just an endless amount of applications. What applications do you see that are you targeting in that?
What I see is 3 major areas. First priority is the selling side of complex, the CPQ. CPQ business systems have not been invested in updating in a while. They are outdated. Not that they're outdated, but they just aren't modernized. So having the digital twin and the strategic partnership I have with RenderDraw, we're able to take that heavy CAD file, bring it into RenderDraw, then bring it into Salesforce, and we're on the inside walls of Salesforce. So now you got their revenue cloud, which is like a CPQ, and the scalability of with Salesforce with enterprise companies. Now you've got that digital visualization. So, but it can also go on its own too. Like Oracle has a CPQ as well. RenderDraw can work with that too. So that's priority 1. To me, priority 2 is service and warranty. And then priority 3 is manufacturing. And the reason I say that is because there's a lot spent in the revenue and selling the big piece of equipment. And that's what the CPQ and digital twin will help. But what gets lost in the shuffle is there's so much opportunity to gain from spares revenue and aftermarket, counterfeit products and this and that, and being able to just-in-time inventory by having true partnerships with the OEM and with the manufacturer or supplier that may have of that part. So service and warranty and being able to leverage agentic AI. So I do a trouble ticket. You had an article a few months back about digital twin and somebody having an error in a process chamber in a fab, and then writing that ticket, and then that comes in, and I'll call it the OEM headquarters takes that agentic AI, takes that issue, that same assemblies across other systems, gathers all that info, brings a summary up and says, hey, these are the possible issues. Now your level 3 or level 4, I'll call it, applications engineer now can add color, add information, and then send it out back to boots on the ground and go fix that. So those are some examples. And because I speak that language, I know how to help get the processes in place and all of that. And then the third one is manufacturing, definitely on the manufacturing build side of it. And the thing about that's a little harder there, but I am developing some partnerships, is that MES data and using that as your processing. I'll give you an example. When I was at Sabre Engineering, we had Cognex cameras, high end, and you've got this ice cream that's going through, like, I don't know how many hundreds per minute, like on a belt, and these cameras are able to check if there's any defect in the decaling or whatever, or barcodes, and then be able to identify it. So then down the line, it gets pulled off, and this is MES data, So if you want to look at and see, like, okay, well, what is that trick point, or what was that? Kimberly Clark had something they were doing with digital twin that It's like, all right, we're not going to do our whole factory, but we're going to do this one discrete manufacturing system, and let's get all of that data collected, IoT data, all of that, and bring it up. And it's an example of like with digital twin plus agentic AI too. So so those are my major areas, and a little bit of roadmap with the manufacturing side.
Yeah. You talk about the data and the amount of data produced. It's just incredible. And like right now with semiconductors, it's a shame because we're using that data for emergencies only. Tool went down, the mistakes already made, the product's already scrapped. Like, okay, now we're going into that data and saying, why did it shut down? I can go into an epi tool and I can pull all the data screens and I can generate 70 pages per second of data from this machine when it's running. It's absolutely an incredible amount of data. But being able to use that data for that, preventative maintenance and for all different types of things, it's absolutely incredible. But in the future, that's going to definitely change. Right now, it's a shame that we're just using all that data for just past mistakes that are already made. But you're using the retail digital. You've been in this for 7 years, working in the retail digital commerce sector, and now you're back into the semiconductor industry. What is the difference you're seeing with digital experience maturity levels when comparing semi to retail digital commerce? What is the difference there?
I have to say, all right, retail. And when I say retail, you got Estee Lauder, you got cosmetics, you've got branded manufacturing, the Milwaukee tools, you got gym shoes. New Balance has been my customer, Converse, Mercury Marine, boats, all of that. I've had over like 50 different enterprise accounts, and them and hospitality, I would say, are at the collegiate level of digital and leveraging digital commerce for the buy experience. Okay. I'd have to say they are lacking in service and warranty support because it's all about really the sell. And when you get to discrete manufacturing, they're very strong in the data side and the processing and the MES stuff. When you're talking large production factories and stuff, IoT 4.0, 5, all of that, they crush it. But when it comes to digital commerce and the selling, that complexity of the sell, they're not at the college level. And I don't want to downgrade it too much, but I would say maybe entering high school, maybe, because it's just so complex in the selling. And I'll bet you they are dealing with Excel health spreadsheets and stuff like that to be able to configure stuff. And they may have some CPQ modules, but nothing's out there that can go do what needs to be done. So that's the gap. And that's what I was trying to explain to some of those companies I was working with, is that, folks, there's a huge opportunity there. So, we can go help them get where they need to go. And I will say one of the things, the difference is that when you're in manufacturing, there's a lot of engineering folks that are there, and they build complex stuff, and and so they may undervalue what the IT department or we can build it ourselves, instead of hiring a third party. That's their core business skill set. And so there's that part of educating that, hey, if we could prove and you could trust us, let us do this so you can focus on your core of making that better John Deere product and so forth, and I run across that. I've seen that a few times at some of the bigger enterprise in discrete manufacturer, batch manufacturing companies. So that's what I'm seeing so far.
That's great. Love it. This is good info, and I love hearing how digital twins and how what you're working on is going to how this industry is evolving, and how we're going to be using this digital twin technology is going to be absolutely incredible. But I love doing this and talking to you and having that stimulating those brain thoughts and making that, seeing how these things are going to change in the future, because there's a lot of change coming.
Yeah. Let me see if we got any notes in here on questions. Let's see. Here's one. There's a lot of fear that AI is going to replace many people in jobs. With lots of layoffs that are going on right now, what are your thoughts on this?
Is it going
I'll
to?
let you go first, and then I've got some thoughts.
Yeah, I believe it is going to alter the industry, right? And we have to retrain everybody. It's not just semiconductor engineering. We have to train everybody has to relearn how to use artificial intelligence. I keep referring to the risk manager. There's a team of most big companies have a team of 6+ people that are in risk management within a company. You're not going to need that team of 9 people anymore. You're going to have a team of 2 or 3 people that are running multiple agents that are collecting that data and putting all that information together and compiling all that information. And so, and being able to generate those reports and to use statistical data to create solutions to the risk management. So now you're going to need 2 or 3 guys that are going to do that. But those guys are going to have to be exceptionally good at using artificial intelligence to running those agents and making sure those agents are collecting the right data and compiling it all together. So is the job going away? No, it's not going away. Is it changing? It's absolutely changing. And we're going to have to use that artificial intelligence in everything in the future. And if companies aren't moving towards artificial intelligence, they're a thing of the past. Period. You're going to have to learn how to use artificial intelligence and everything. Even my friend I was talking to this weekend, he's a lawyer. He said, "Oh my gosh, everything has changed with artificial intelligence. Now we're doing, we're able to collect so much information and be able to do all of our jobs so much faster now." And it really puts the question on, hey, we were doing 10 days of discovery. Now we're doing 3 days of discovery. That they charge money for that and they make their money there. So how are they going to be able to charge? And now they have to look at how they're going to charge for discovery and for legal discovery. And because it's no longer just it happens so fast, but it's changing every industry in the world. And whether you're a lawyer, a risk manager, you're a semiconductor, no matter where you're in, it's going to alter your career for sure.
That's a good point, because the other side of it, I'll call it as like optimization, like your example with the law firm. All right, it used to take 10 days of discovery. Now it's down to 3. Yes, now you're going to start looking at the water levels lowering. So where are my rocks that I have to cut costs on or so forth is one thing. The other thing, though, is now I have a process weapon in a way to be able to do things faster and more accurate. So that's why you want to hire us. We're the law firm that's leveraging this and that. And I will say, for those that, for AI, you have to get your hands on the keyboard. You have to use it. And when you're experienced, you're able to ask it the right questions or learn. You're able to also tell that, all right, well, maybe that's not right. Let me go research this or add my piece of color on it too. So then it's like a tool to enhance you to do more. But definitely some jobs are going to get lost. Like the thing about the level 3, level 4 support service person, that agentic AI taking and doing all that research across all the different parts of where the tickets were 4 or 5 months back, even, a level 1, level 2 support engineer is not going to be needed, and so the companies have to be aware of, okay, well, if I have folks that are being replaced, is there opportunity to possibly retrain them to do something else? Absolutely. And I'll give you an example. I'm thinking about these spare parts identifiers. The tech writer that's going to be writing that, well, with Digital Twin, that's going to be a game changer. But that tech writer can learn the application, can learn the Salesforce side, can learn taking the AutoCAD files and do the processing. So you're not like losing the job. So it is going to be challenging. It's really going to be about too, like, of how how do you work towards retraining some of the workforce, because remember when robotics 10 years ago, like robotics are going to replace everybody, and it hasn't done it yet. It has done it some areas, but it's created new jobs though too,
Right. Yeah, definitely. And robotics is a whole nother industry that, wow, that's going to be a big change in the future. I was just listening the other day about Target, trying to debate whether or not they wanted to go into like a drop ship type of business, versus stores. They don't have to worry about theft. They don't have to worry about having a store open. They don't have to worry about employees or anything like that. I don't know if you've seen these Amazon fulfillment centers where they have tens of, hundreds of robots running around, picking up and filling these baskets. And can you imagine that being your grocery store in the future? Like, I mean, you're just going to go in and order all this stuff. It's going to get picked by a robot, and then it's going to get dropped off at the door. You're going to pull up and pick up your bag and drive away. There's not going to be any more picking that information, going into the store and walking around and deciphering what you want and everything like that. I think it changes everything, right? Robotics and then, of course, what is the foundation of it all? Chips. The chips are the foundation of it all, right? And so, this is the ground foundation of it all. And so they're going to be running the robots. The sensors are going to be running the robots. There's going to be so much of this complicated ecosystem that's going to be, that just hangs on a thread of geopolitics or natural disasters or something like that happening. 90% of the world's chips, advanced chips in the world, are made in Taiwan right now. And so, how do we diversify that ecosystem and that, more, able for a lot more, dealing with risk management and preventing that risk, and so, there's so much happening, but robots is going to be a big change in the future as well.
I remember seeing, and I'll ask another question. There was this KUKA robot that I saw the article. It was a couple of months back, and it's this big robot that goes in the field to install the solar panels on the racks in a solar field.
Oh, cool.
I forget the name of it, they called it, but using high-end cameras, using AI, and just amazing piece of equipment, like just gigantic. And so, But here's another question that came up. Compared to other chip renaissance booms that you've seen over the past 2+ decades, how does this one compare to the others that you've seen in the past?
Oh, it's vertical. It's absolutely the trajectory is just vertical. It is. We've, like I said, this Moore's law has been like this, and 74 years we've watched it climb and dip and climb and dip, and it's like this. It's absolutely parabolic. Where things change. The reason being is cost. If a CEO's, his fiduciary responsibility is to do things to make the company the most money. And it's no longer going to be, I question things like capitalism. Like, where does capitalism land in this thing when the fiduciary responsibility of the CEO is to make money, and we're replacing lots of jobs with that. Will we see change? Will we see new jobs come about? Yes, absolutely. But it's going to be a big change really fast. The reason being is because companies are going to make more money. And when you throw that cost that capital cost in there, and what how they're going to be able to make more money by implementing AI, robotics, and all these different types of things, like they have to do it. And so it's there's no question about whether they're going to do it. They're going to do it, and they're going to do it fast. It's their fiduciary responsibility to do that. So and they have to. It's going to be supply and demand now. It's going to be whether or not we can make the chips and whether or not we can make those robots fast enough. They're building these data centers at exceptional rates. We have $1 trillion of data centers going up around the world, and they're building them in astonishing speeds. Like, the faster they get them up, the more money they're making. And so everything is dependent on, this technology now. And faster we get this technology going, the
Mhm.
more money companies are going to make, and the faster things are going to change.
Yeah.
So
Thank you. Thank you. Well, we're getting close to being up on our time. I do want to ask you, one, I want to thank you. This has
oh, my
been
pleasure.
great. And I know you and we could geek out for hours on this
Absolutely.
different topics. But for today and the audience that's out there, both there's the semiconductor audience, there's the digital commerce audience. What advice do you have that you want to leave as parting points to this audience?
Be ready for change. Things are going to rapidly moving. Technology is just at this rapid change right now. And be pliable. Be pliable to learn,
Yes.
learn new things. Keep your eyes
Mhm.
out there. Do not be, you know, do not be a hardhead and saying I don't need this technology.
Mhm.
This will pass you so fast, and you will be wondering why that guy does 10x what you do, because
Mhm.
he's able to use artificial intelligence and
Mhm.
robotics and other things.
Mhm.
It, just be ready for it, and it's coming, and it's coming as a tsunami, and it's going to absolutely hit us so fast and so hard, and
Mhm.
be ready for it, because this is where the biggest evolution of we're going to see so much change. I believe we see digital currency come through. I believe we see things like like that, and we see so much change happening in the next 10 to 15 years. The next 30 years is absolutely, I have a 9-year-old. I can't even imagine the world he's going to live in
Yeah.
when he's
Yeah.
my age. But,
Mhm. Mhm.
what is, being ready for this change and this movement of the tsunami and this technology that's coming at us, and
Mhm.
adopting the technology and taking the time to learn it,
Mhm.
being pliable in that way is absolutely something
Mhm.
that everybody has to do.
Yeah.
So,
Yeah. No, that's great insights. I think along that same lines, like the change technology. I mean, to be able to last in this journey of the 37 years, and I still got more. I ain't done yet.
no,
And I think
me
I've been
neither.
across like 6 technology nodes. Change is always there.
Yeah.
And I don't know, maybe just because it's technology and I love that, but the constant ability to adapt and, like
Hmm.
you said, pliable, but
Hmm.
also, and I'm going to say this to the boomers out there, and I'm one of them, you know, you don't want to be crusty.
No.
Okay. You got to be able to get along with multiple generations of people. You
Yeah.
got to be able to let them do their ideas. And for those leaders out there, you know, risk, it's okay to let them have some risk, but having that conversation that just call me for help if you need it. Don't let it completely fail, because a lot of times you can have it and it can fall. You can be 80 or 90%. It could fall apart. It's still fixable, and then you can
Mhm.
still close out the race.
Right.
So being able to do that, because it is going to take leadership and in an emerging of, I will say, newer leadership in a way,
Yeah.
versus, like, because we have different types right now, but newer leadership that really cares about the employee,
Yeah.
is empathy, leads with empathy, but
Hmm.
also has accountability, and
Hmm.
that is what's going to help make things go. So
Yeah.
yeah, and it's funny that you say the change and pliable. The background screen that I took this morning, of the wave and
Wave.
that pipeline, and either you're going to surf that and ride that wave and come out of that pipeline, or you don't adapt, you're just going to get crushed. And
Absolutely.
but if you get crushed, there's always, you can live for another day and surf another pipeline. So, well, thank you so much. This has been great, Robert. And I just want to close with, thank the audience too, that we do have what the format is going to be for these podcasts, is that I'm going to have three more to close out the end of the year every 2 weeks. They're going to be on a Monday, November 10th, same time, 2:30 to 3:30 CST, December 1st and December 15th. On December 1st, we're going to have Stu Shepard I'll call him, he's like the godfather of industrial robotics. He's a legend. If you know KUKA Robotics, I think he was the president of that company. I've known him for a few years. The guy is just phenomenal on industrial automation and large scale robotics. And then on December 15th, we're going to have Gina Tabasso, who I just recently met, and she is awesome. Like, I'll call her, she's like a Six Sigma in process, but also agentic AI and AI in that industrial equipment manufacturing, MES stuff and so forth. So that'll be great. November 10th, I have an opening. So I don't have somebody to fill that yet, but definitely take some comments or so forth if you want to get on the show. I'm going to be hunting too. I know I'll close out by the end of the week and have somebody. So, but the format then when we go into 2026, it'll be always the second Monday and fourth Monday of the month. And I'm going to move it up to the morning slot, like a 9 or 10 o'clock, probably 9 o'clock. This way we can hit the Europe side of the house as well. So thanks again, everybody. And we definitely appreciate your time. And you guys have a great afternoon. Okay. Take care.
See ya. Bye.
All right. Bye-bye.